All right, let's look at this problem here. This shows atoms, and we want to find out the number of grams. So we've got 2.5 times 10 to the 22 atoms of gold. So I know I'm going to be working with the molecular weight of gold, which molecular weight is the number underneath each of the element symbol. So look here, hydrogen has a molecular weight of 1.008. Lithium, the Li, that has a molecular weight of 6.941. Beryllium, the next to it, has a molecular weight of 9.012, blah, 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 blah. They all have a molecular weight that gets bigger as the atomic number or the proton number goes up. So the number up top is the proton number or the atomic number, never changes. And the decimal place number underneath is the molecular weight. The molecular weight's important because that's the number of grams in 1 mole. So the element Li, lithium, that has 3 protons and 6.941 grams in 1 mole. This element number 4 here, beryllium, that has 4 protons and 9.012 grams are needed for 1 mole of beryllium. Okay. Now, be careful. They're not starting with moles, they're starting with atoms. So in chemistry, they're going to do a lot of this, going from atoms to moles to grams, right? Or grams to moles to atoms. We're doing the first conversion, the atoms to moles to gram. So the steps to do that are, first for atoms, we're going to divide by Avogadro's, huge number. Okay, I don't know how to spell it. I don't know if that's right. I'm going to just assume it is, ignore that. And then we're going to multiply by the molecular weight of gold. And you'll see why of gold, which is AU. You'll see why when we do dimensional analysis. AU is the symbol. All right, let's make it happen. So I've got 2.5 times 10 to the 22 atoms. Let me just fix the 22. Okay, of gold, right? Gold. So all I got to do now is turn that, follow this here. I got to go atoms to moles. I can't go right to grams, can I? See, you got to go over the bridge of moles. Okay? So you can never go directly grams to atoms or atoms to grams. You got to go through moles. Moles is the bridge. So let's go atoms to moles. Okay, so how do we do that? Well, we just remember Avogadro's number, dimensional analysis. Okay. Let me just see, put it in here. 6.022 times 10 to the 23 atoms in 1 mole. Let me fix the 23, make a little. Okay, in 1 mole, that's Avogadro's number for all molecules and compounds. 6.0222 times 10 to the 23. So what does that leave us? When I do that math, okay, I'll do that in another box now. Well, I could see the units are going to cancel. The atoms cancel, right? Atoms cancel with atoms, and I'm left with, excuse me, I made a mistake here. Mole, not molecule. My mistake. Sorry about that. So the atoms cancel and leave me with a mole. Okay? Avogadro's is 6.022 times 10 to the 23rd atoms in 1 mole. So now the atoms cancel out. Now I'm left with the 2.5 times 10 to the 22 divided by Avogadro's number. So let's first do the exponents. Don't worry about the other numbers. So let's do that in another block here. All right. So when I do 10 to the 22 divided by 10 to the 23, okay. Suppose I could put it on top the way it's drawn there. Okay. We're going to do that division first. When I divide exponents, 10 to the 20, they have the same base 10. They both have, so I can just divide I could just combine the exponents. What do I get here? They have the same base 10. 10 to the 22 divided by 10 to the 23 is going to be, ready for this? 10 to the 22 minus 23. Now let me raise that up. Okay. So what's 22 minus 23? That's going to equal 10 to the negative 1. Let me just fix that. So I know that. So now that makes the math a lot easier. So the exponent portion is just turns out to be 10 to the minus 1. So this becomes, I can get rid of the 10 to the 22 and just make it 10 to the minus 1 now, because I divided those out in that little other box. Get rid of this one altogether. Now look at the math. It's much easier. The atoms cancel out. The 10 to the exponents cancel out. And now it's just 2.5 times 10 to the minus 1 divided by 6.022. I can even get rid of this. So when I have it times 10 to the minus 1, what do? How do I just get rid of that? I like getting rid of things. 2.5 times 10 to the minus 1 is just, I move the decimal which way? To the left or to the right? Does 2.5 become bigger or smaller? What do you think? When you multiply times 10 to the minus 1, there's a negative there, it becomes smaller. So make it not 2.5, but 0.25. It's always proper to put a 0 first. So 0.25, get rid of the 10 to the minus 1. I just got rid of it. So now it's just 0.25 divided by 6.022. And that turns out to be 4.15. Excuse me, 0.415. Let me double check the number. 0.25 divided by 6.022. Yep, 0.0415. What are the units? Moles. Because Avogadro's turned that into moles. Halfway there. We did the difficult math. This was the difficult math. Got rid of the exponent portion. And we got moles. So now we got to go moles to grams. How do we do that? We got to use the periodic table, because in the periodic table, all these decimal numbers underneath are the grams per mole. And I've got a mole here. So what do I do next? Well, I got to use dimensional analysis and turn moles to grams. So I got 0.0415 moles, right, from the last calculation, 15 moles, okay? Now, dimensional analysis, I want grams, so I got moles on top, okay? So I want to cancel the moles out, so underneath I'm going to have what symbol? Moles or grams underneath. I want to get rid of moles, so I have moles on the bottom. You can write it that way, or unfortunately they write it two ways, like that too, just MOL. That's the more common way. And I want moles per gram, okay? So what is this conversion number here? Now I'm working with gold, right? I know I'm working with gold, so I got to go to the periodic table and find this value of how many grams in a mole. Okay, so gold has a molecular weight of 79. Sorry, it has a atomic number of 79. Let me correct that. Gold has a atomic number of 79. I don't know the molecular weight. So what is the molecular weight of gold? So I'm looking for the number 79 in the top number. And there it is, gold. And I'll put it in red here. I got to format out of shape. Get rid of the center stuff. No fill. Make that red. Make it that color. So gold here on the periodic table has 79 protons, but I don't need that for this one. I need the molecular weight of it. The number underneath is called the molecular weight. So that's 196.1, almost 200, right? 196.967. It's pretty heavy. So what do I do with that number? The molecular weight, the number underneath, the decimal number, the messy number, let's call it, is the grams per mole. So don't put the grams down here. A lot of kids make that mistake. Most kids I've tutored at least 50 kids. They always get this, they often get it backwards. Put the mass here, grams. This is grams per mole, not moles per gram. That 196.967 is the grams per mole. In fact, they should put on a periodic table, I don't know, I would make a better, they just suck at this. They should call this grams per mole. They don't, but it's kind of hard to write in here, but you could actually physically write on your table grams per mole. Grams per mole. I mean, that would make it a lot easier, right? If I could start over with the system, I would label all these numbers underneath gram per mole, and I would label all the top numbers proton number. Like I would call this protons up top. Like the number 1 here for hydrogen, protons. Lithium has 3 protons, but they suck at labeling in chemistry. They really suck at it. And there's so many different names, it sucks. So just try not to get too frustrated. I was miserable for a long time. All of these decimal numbers underneath are grams per mole. So grams per mole. So now just multiply it out. So 1 mole is of gold, AU, that's the chemical symbol, is 196 grams of gold. Okay. So now I can cancel the mole out, and I'm left with grams. Mole. So now 0.0415 times 196.97. I do that math, and I get 8.17, I think. Yeah, 8.18 grams. But significant digits, which drive me crazy. We had 2.5 in the problem, so we're limited to 2 significant figures. So you got to make this 8.2 grams, and that is your answer. That many grams. So again, we started with atoms, used the bridge of moles, and then once we got moles, we turned to grams by using the molecular weight, because all these numbers underneath, although they never tell you this in chemistry when they teach it because they're not good at it, the numbers on the bottom of the table are all grams per mole. In fact, let's just fix it right now. The top letter is protons. I'm going to put P. I'll make it small. 10 to HOMA. Okay, make it 8. Make this like 10. Okay, the number on top is P. And the number underneath is the molecular weight in grams per mole. It's the molecular weight, and the units are grams per mole. You're going to hear your chemistry teacher call it molecular weight. She really means that's the number of grams in 1 mole. But they also call it molecular weight because they suck. Don't get too frustrated. That's just the crappy system. Okay, there we go.